Hello dear students, welcome to Tejuma YouTube channel. In this video I am going to give you the list of formulae from the chapter Ray Optics. This is the 9th chapter from 2nd PUC physics syllabus. So without a delay, let us start with the first formula. So before that you should know these basic terminologies. Hope you have already studied here. In this video I am mainly focusing on the formulae. You can just go through these theoretical things now. So first of all, we have the laws of reflection. So wherein we have the light ray when it incident on the reflecting surface, it gets reflected by a particular angle. So we measure the angle of incidence and angle of reflection with respect to the normal. So what is the normal here? Normal is the perpendicular line drawn to the surface, so at the point of incidence. So the angle between the normal and the incident ray is called angle of incidence. So the angle between reflected ray and the normal is called angle of reflection. So in case of reflection, the first law is angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of reflection. In this case, that is theta. That is the angle between the normal and incident ray and normal and reflector ray, which is same. Then we have the second law of reflection. So that is incident ray, reflected ray and normal drawn at the point of incidence all lie in the same plane. Moving on to the sign convention. So this also you must study. That is giving positive sign or negative sign for height of the object, image distance, object distance, all those things that you should learn. You can just go through the theory part. So then we have the next formula, that is the relation between the focal length and radius of curvature. So that is given by F is equal to R divided by 2. Yes or no? Focal length is half of the radius of curvature. It may be mirror or lens, and radius of curvature is 2 times the focal length. 2 times the focal length. So from where to where we measure the focal length? It is the distance between the pole and the focus. So focal length is the distance between the focus and the pole, and radius of curvature is the distance between center of curvature and the pole. Okay, so this is one thing. Then we have mirror formula. So what is mirror formula? Here we have mirror formula. So 1 by F is equal to 1 by V plus 1 by U. So this relates the focal length, image distance, object distance, and magnification is given by image height divided by object height. So that is equal to minus image distance by object distance. This is especially for mirror. Okay, so mirror equation is 1 by F is equal to 1 by V plus 1 by U. This is called mirror equation. And then here we have the magnifying power or magnification or magnifying power. Okay, then we have laws of refraction. So first law is the incident ray, refracted ray and normal drawn at the point of incidence all lie in the same plane. And second law is called Snell's law, that is given here. It's very important one, according to which we have the ratio of sine of the angle of incidence to the sine of an angle of refraction is a constant, that is sin I by sin r is equal to n2 by n1. So let me write it again. Sine I divided by sine r is equal to n2 divided by n1, that is equal to n21, that is equal to, I can also write it as v1 by v2, because refractive index is inversely proportional to velocity. If refractive index is more, the velocity of the light will be less, and that is equal to lambda 1 divided by lambda 2. So if velocity is more, lambda is more. If velocity is less, wavelength is less. So this is the Snell's law. Okay, so do you remember this? So what is n here? N is refractive index. V is the velocity. And lambda is the wavelength. Lambda is the wavelength. Then we have the formula for the absolute refractive index and relative refractive index. So the absolute refractive index is given by C by V, where C is called speed of light. That is 3 into 10 to the power 8 meter per second, and V is the velocity of light in a given medium. Okay, and then refractive index of second medium with respect to first medium is given by n2 by n1, that is equal to v1 by v2, so that is equal to lambda 1 by lambda 2. That is called relative refractive index. That is also equal to CNR by CNR. Okay, relative refractive index. Then we have the formula for lateral shift and normal shift. Lateral shift is given by L is equal to 1 divided by cos R1 into sin I1 minus R1. That you can refer what is I1, what is R1. You can refer the diagram for that. And then we have normal shift. Normal shift is given by T into 1 minus 1 by N, where T is the thickness of the medium through which the light is moving. So N is the refractive index of the medium. So most importantly, for board level we use this, like refractive index of the material is equal to apparent depth divided by real depth. So both are very important. Then we have Snell's law for critical angle of incidence. So this is also important formula, that is given by sine critical angle. You can write it as sine C also, or sine IC, is inversely proportional to n. So if you want to calculate IC, you can take sine inverse 1 by n, or if you want to find out n, you can take 1 divided by sine IC. So these are the different formulae. These are the different formulae. So for Snell's law for critical angle of incidence. Then we have the refraction through single spherical surface. The relation is given by n2 by image distance minus n1 by object distance is equal to n2 minus n1 by radius of curvature. Okay, so this is for refraction through single spherical surface. N2 by image distance minus or plus n1 by object distance is equal to n2 minus n1 by radius of curvature. This can generally be written as refractive index of second medium divided by image distance plus refractive index of first medium divided by object distance minus n2 minus n1 by radius of curvature. So in general you can remember this. So then we have the lens formula. So lens formula is given by 1 by f is equal to 1 by v minus 1 by u, because object distance is left side, image distance is right side, and for convex lens we take f as the focal length. So here I can give the magnification formula also. So that is h image divided by h object is equal to v divided by u, minus will not come. Next we have the magnifying power of lens. Just now I have written, I'm ready to write it again. H image divided by H object is equal to image distance by object distance. Next we have the power of the lens. Power of the lens is given by P is equal to 1 by F. Reciprocal of focal length will give you the power of the lens. Next we have the equivalent focal length and the power of two lenses in contact. If two thin lenses are in contact, you can write it as 1 by F is equal to 1 by F1 plus 1 by F2. So F1 and F2 are the focal lengths of two thin lenses. F1 into F2 divided by F1 plus F2. Then we have power of the lens, that is P1 plus P2. Okay, so for n lenses we can continue like 1 by P1 plus 1 by P2 plus 1 by P3, so on like that. Then angle of minimum deviation, here the formula for relative refractive index is important. So that is N21 is equal to sin I divided by sin R. From the diagram it is known that A is equal to R1 plus R2 and delta is equal to 2I minus A. So for angle of minimum deviation, okay, so R1 is equal to R2 which is equal to R which is equal to A divided by 2 also you can write, and I is equal to delta minimum minus A, this is plus A, no, just a minute, we have I is equal to delta is equal to delta 1 plus delta 2, delta 1 is I minus R1 plus E minus R2, so from that I minus plus E minus R1 plus R2 you are getting, so therefore you will get that as delta is equal to I plus E minus A. For critical angle of incidence you will get, let me write it again, delta minimum is equal to 2I minus A. So therefore I is equal to delta minimum plus A divided by 2 and R is equal to this much. I is equal to this much. Therefore we write the final formula like this. N21 is equal to sin I. I is delta minimum plus A divided by 2 divided by sin A divided by 2. This is the actual formula. Then we have optical instruments, microscope and telescope, wherein the microscope, simple microscope, we have the magnification. The magnification of simple microscope is given by M is equal to 1 plus D divided by F, where D is the distance of the image and F is the focal length. If the image is formed at finite distance, if image is at finite distance, this is the formula. Okay, so then second formula is M is equal to D divided by F if image is at infinite distance. So these are the main two formulae for magnification of simple microscope. Okay. Next we have the compound microscope, wherein we have objective and eyepiece also. Yes or no? So where if you write the magnification is given by the product of magnification produced by objective and eyepiece. By product objective magnification is given by L divided by Fe. F naught into 1 plus d by Fe. This is for image formed at infinity. Now, finite distance. If you consider the image formed at infinity, you will get 1 by F is equal to, or F naught is equal to just d divided by Fe. Image is at infinity. Then we have refracting telescope. For refracting telescope, the magnification is given by F naught by Fe. Also we have one more formula that is called tube length of telescope, that is given by L is equal to F naught plus Fe. Okay. So then we have reflecting telescope. For this magnification is not given. So this is all about this video, dear students. We'll meet you in the next video with new ideas. Till then, take care. Bye bye.